right, guys, we are going to start chapter 2, simplifying expressions. And I realize we didn't have our test on chapter 1 yet, but because I skipped a couple sections in chapter 1, I'm going to add a couple sections from chapter 2 before we take our test over that material. So section 2.1 is called Basic Assumptions, and there's really 3 types of problems. The first of which is adding like terms and that's probably the most important of the types in this section, just because you see it most often. And to explain the concept of like terms, you might already have an idea. I think I've mentioned it before. We're going to make a little table. So like terms, not like terms, just so you can get a feel. All right, so like terms would be, for example, numbers. -9, it could be 7, 0, 6.43. Numbers are alike. That means numbers will add with other numbers. But you can't take a number and an x term. Those cannot add to each other. Another example would be, let's say, 2x and 3x. Those are alike. I can add those together to make 5x, but I couldn't, for example, add 7 and -5x. You can't add a number with an x term because they're not alike. Other like terms could be, you might have a bigger exponent piece, 5ax. If the variable part is identical, then those are like terms. And it's really the variable part that defines what a like term is. So an ax term will add to an ax term, but I can't add an ax term to, let's say, a bx term, because those aren't exactly alike. I could add an x to the 3rd term with another x to the 3rd term, but I can't add an x to the 3rd term with an x squared term, and so on. So the variable numbers are always like each other, and numbers can only add with numbers. And besides the numbers, the variable piece has to match exactly to be considered a like term. All right, so the types of problems you're going to see will be, I'm just going to go through examples. Here, we'll just do A, B, C, D. 3 plus 9m plus 6. And the directions are going to say simplify. But remember, simplify means solve. So you want to add up everything that can add up and simplify as far as you can. So the number is going to add with the number. Number and number will add to each other. But the numbers cannot add to the m term. So I'll get a 9 for the 6 plus 3 plus 9m. And that's the final answer. Let's see if I can let me get a highlighter to do this. All right, so sometimes these are fairly simple in this section, but they can get more complex later on. So sometimes it's helpful to either highlight the like terms or circle them. Let's see, example 2. 9x minus 4 plus 3y plus 7. Okay, we want to simplify that. Well, we need to figure out what terms are alike. first of all, any place you have subtraction, you want to keep, change, change. Now I know my number can add with the other number, and then the x term cannot add to the y term, so those are two separate ones. So the 9x is going to stay 9x, the 3y is going to stay 3y, and negative 4 plus 7 will add to a 3. Those cannot add to each other. Okay, let's see if there's any more like that. Let's do... Okay, 6p plus 2 plus 11k minus 3k. All right, so looking for like terms, I have one number, and I have a k term that can add to a k term, and then the p term can't add to anything. So the p term is just by itself, the number is by itself, but the two k terms can add, and I'm going to keep, change, change. So when you add like terms, it's the number in the front that you're going to add. 11 plus negative 3 is 8 k's. Kind of like you have, a k is like an object. You have 11 k's, and then you take 3 k's away. That's going to leave you with 8 k's. None of these can add to each other because they're all different. Okay, I think, yeah, maybe one more. Oops, I'm almost off. Example 4. How about 10a plus 6 minus 4n plus 7. Okay, simplifying this, looking for like terms. Well, I have a number and a number that can add. The a cannot add to the numbers, the n cannot, the a can't add to anything, the a term, the n term can't add to anything. But I will keep, change, change right there. So I get in the end 10a. The order that you write these doesn't matter, because it's, if you do a keep, change, change, then everything's addition. You can have your final result in any order. Minus 4n plus 13. Okay, so that's adding like terms. The second kind of problem is, let's see, multiplying terms. All right, and so examples would look like 5 times 7x. Now here, this is all multiplication. The parenthesis means I'm multiplying 5 by 7x. There's no addition, no distributing. And so you want to multiply the numbers together. Multiply numbers together. So that's going to be 35. And you put the numbers in the front. You put the final number in the front. Put in front. Drop parenthesis. So the final answer is 35x. Number in the front, then the variable parts, no more parentheses, and that's your final answer. So example 2. 2m times 3p times 5k. All right, you have three terms multiplied to each other. So just like here, multiply the numbers together. 2 times 3 is 6, times 5 is 30. And then you put the letters together, MPK. I usually put them, normally they're alphabetical, but you can put these in any order. No parenthesis in your final answer. And okay, I think I'm gonna stop right there.